All right, so now we need to find a parametric equation of a line with a slope of 2, and it's going to pass through that point -2, 1. Okay, so it goes through -2, 1. Now, as time passes, so if that was our first, x was -2 and y was 1, okay, what's going to happen is we're going to be drawing this graph. We're going to go over a little bit, and we're going to go up a little bit. Okay, so we're going to add a little bit to both the x and the y as time passes. So the general form of lines is x is equal to the original point, and then we're going to add a little bit in the horizontal direction, and the y is the original, if this was x0, y0. Okay, so we go to that original point, and then we add a little bit in the vertical direction. Now the slope is telling us exactly how much to add. Okay, so if the slope is some a over, or I'm going to do b over a, okay, then this is rise over run. Okay, so it makes sense that the horizontal amount would be added to the x, and that the vertical amount, the rise, would be added to the y. Okay, so that's kind of what's going on. So let me show you here. If I have a slope of, here my slope is 2. Well, I'm going to rewrite that as a fraction, so that's equivalent to 2 over 1. So my b is 2, my a is 1. Okay, so we use our x equals initial plus a t. All right, well, a is 1 times t. Y is the initial y plus a little bit of vertical. That's the rise times time. Okay, the rise in this case is 2. So that's how we come up with the parametric equations for a line. And now we can play around with seeing what happens. Okay, so let's go from t equals 0 to 1 to 2. We could plug in more t values. We could be at -1 if we wanted. We can start wherever we want on t. Okay, but let's see. We've got x is -2 plus 1 times t, which is 0 in this case. So that would be -2. Y is 1 plus 2 times 0, so that is 1. All right, at a t of 1, we have x is -2 plus 1, so that is -1. Y is 1 plus 2t, so 1 plus 2 times 1, that would be 3. Okay, and then plugging these in, we would get 0 and 5. So now we can go ahead and graph. Okay, so at t equals 0, we're at the point -2, 1. At t equals 1, we're at -1, 3. Okay, so we added a little bit on the x direction, or horizontal, a little vertical. Okay, and now at t equals 2, we're at 0, 5. T equals 2, and that would continue. And we could have started back further for our t value as well. So that is a continuous line. It's just being drawn from left to right. Okay, now let's look and explore what's going on with parametric equations as they relate to polar equations. Okay, so polar equations, we have these forms: x equals r cosine theta and y equals r sine theta. So these are actually equivalent. If we just let our parameter, our t, replace our theta, then we can just rewrite these as parametric equations: x equals r and y equals r cosine t. Okay, so they work actually very well together. That's an easy switch just to let our parameter be theta. Okay, so now our example is r equals sine of 2 theta plus cosine of 2 theta. Okay, but since we're going to try and rewrite this in parametric form, I'm going to replace my theta with t, cosine of, oh, this is just a theta. I'll go ahead and fix that. So this would just be t. Okay, so there's our r. And now we're just going to plug this in to our parametric equation. So x is equal to r times cosine t. Okay, plug r right in here. Use substitution, and we would get x is equal to r, but I'm replacing r with sine of 2t plus cosine of t. Okay, and x is equal to r cosine t, so we still need to multiply by cosine t. Okay, whoops, y is equal to r sine of t. Just using substitution, replace r with sine of 2t plus cosine of t, and then that's multiplied by t. And I'm not going to ask you to graph this by hand, although we could. That would be fine, right? You just plug in some different values of t at 0, at pi over 6, at pi over 3. You know, we can do this, but we can go ahead and pull out our graphing calculator. All right, so it took me a little while to type all this into Desmos, and now we can see what happens over time as my theta, or as my t goes from 0 towards 2 pi. That took me so long to type in, I'm going to do it again. I'm going to show it again, it makes me happy. Okay, there we go. We're graphing our graph. So Desmos really does work. You just have to be careful of all your different parentheses. It's a little confusing, making sure to type all that in correctly.